First thing, Happy New Year, everyone. I know it's middle of January, but here we are. I want to quickly speak about how I'm learning for this channel. For most of the video, I'm working through a book called Make Electronics, 3rd edition by Chris Black. I don't show the contents of the book in the video because, well, it's copyrighted material. And if you want to support the author, you can go buy a book. I really like this book. It's very practical. As it says at the top, burn things out, mess things up. That's how you learn. And I agree with that. Especially, I'm not a professional at electronics, and I'm learning this for practical reasons. I want to make use of circuits and I want to understand what the things do, but I'm not going to mass produce anything and put it on stores and so on, and I don't need to comply with any kind of safety regulations. So my circuits probably make more noise than they should and all of that. But this is a hobby. This is my target audience as other hobbyists that just want to learn. I learn this way because I struggle with memorizing things, but I'm good at understanding concepts. So reading about it, learning to read schematics is a bit more difficult for me than doing the thing, seeing what it does. This is why I love the oscilloscope. Seeing things on screen, what is going on, is very important to me to see what goes on. I want to give a tip to younger people that are learning. This I learned from experience. It didn't come to me naturally. My way of learning does not work for if you're learning to become a lawyer or so on, and you need to memorize a lot of stuff. This mainly works for practical stuff that you're going to do, like this electronics, or if you're learning to code and so on. One thing I've learned is when I get stuck, sometimes you'll get a topic that you'll get stuck on. Move on and you'll know if it was important. If it was important, then you come back and make sure you learn it. But if it never comes up again and it's never a problem, then if you spent days trying to figure it out, then that's wasted time in my opinion, especially, again, for practical reasons. For me, I favor being able to look stuff up rather than memorizing it. Some stuff there's no point in memorizing lists of things if you can look it up. If you look the same thing up enough, you will remember it and you won't have to look it up the whole time. Important stuff will stick to memory, unimportant stuff you will never remember. With that said, this is a circuit I want to use to demonstrate this. Now, I read in a few posts and so on why people add capacitors to the start of their circuit. So in this case, you would add it right after where the power is. And I read about it, but I never saw it before this. And you can already see the issue right here. That is extremely noisy. And I read, and I've been doing it because it was a rule that I was taught through other books or tutorials and so on. But adding capacitors to the start will remove this noise. This noise comes in from the power supply. It's probably stuff picked up along the way from noise from power supplies, from other power supplies, and this long wire that I'm using to get the power here. Yeah, for this long wire, you can see it ends up here. So let's actually add a bunch of capacitors and see their different results on that timeline. How big a difference do some different sizes make? Yeah, is it worth it? I think the technical tip is adding capacitors to the start of the circuit is decoupling capacitors, and depending on the size, it will remove different frequencies. And I'm pretty sure there's some math you can do to calculate what capacitor you should add. I do not know that math, so my approach is going to be to try different capacitors and see their impact on this specific frame. So let's start with 100 microfarad capacitor. It's like a tiny flat one. Put the negative side on the negative side, and we immediately have quite a lot less noise there. You can see that instantly. I'm going to remove that one that was 100 microfarad. I don't actually know what the capacity of these are, but I have two ceramic ones. And one is 104 and the other one is 103M. Now, in the book, he explains the number is nothing to do with its capacity, it's to do with the size, the physical size of it. So yeah, I think you can look them up and see which ones you need. So if I add that one there, doesn't look like anything changed. There's a very small change, as that was a 103. Let's try a 104. That seems to have an effect. Oh, wow, okay. So both of these are marked 104, but the larger one is having a bigger effect, so I'm going to keep that one. I did that one and went smaller. Now let's go slightly bigger. Here I have a 470 microfarad. Let's see the effect that one has on my noise. Oh, quite a lot. Is that better than the other one? It's about the same, I think. I would have to capture some snapshots and compare. See, I actually think the 470 is better, so I'm going to keep that one. Let's see 1000 microfarad capacitor, 16 volts, but let's add this more beefy one across there. You can actually hear it charge. This one does do quite a bit. Now let's combine it with a little one. Seems to have very little effect. So I'm going to keep 1000 microfarad capacitor coming into my circuit. So one thing to note when doing this is this capacitor needs some time to charge. And when I plug it in, I can hear my power supply switch on. That's probably one of the capacitors inside that thing. That's because this thing has an inrush current. I've also read that you have to be careful with their charge. They can draw quite a lot out of, or they can cause large currents to go across earlier parts of the circuit like this one. Adding resistors before in line with the capacitor will slow down its charging. Now if I press this button, what's going to happen is this capacitor is going to charge slowly instead of quickly like this one, because I've added resistors in line. That slows down the charging and you'll slowly see that light come on. And if I let go, the light will slowly turn off. Now this isn't something I can show well on this, so I'm going to switch this off. Okay, I've gotten a bit closer to this. Make sure I don't move. Now if I press this button, we'll close the circuit through the capacitor and make it charge slowly. And if I press this one, it just discharges the capacitor through another resistor and the power is completely gone. This also demonstrates that the oscilloscope does not replace your multimeter. Don't throw it away if you ever get one. What I've done is I've set up my black one to ground. That'll measure the negative. And I will measure the difference across the capacitor as the voltage climbs. So I'll put the positive in there. And if I press this button, you'll be able to this time see the capacitor charge up. The voltage will climb to around 5 volts. Okay, I'm gonna call it there. Now, if I let go, it discharges because there's no more power coming into the capacitor, but the capacitor is now powering the circuit. So yeah, I've got it back at full charge now. Now, this is one way the capacitor will stabilize the circuit. Another way of, I guess, getting around an unreliable power supply. So you can see as I'm pressing this, every time I press, I add power. Every time I let go, I'm letting it discharge. And the capacitor is keeping the circuit stable and the light on. It's like a little buffer, a storage, as I'm doing this. So that's one of the uses, is if one part of your circuit is switching quickly, it doesn't affect the other part of the circuit. The other button just discharges it almost instantly. I want to explore capacitors a bit more, specifically when dealing with waves, and I'm hoping to end up at some audio stuff later. We've got some speakers, and I'm hoping in this book I'm learn enough to generate a tone. One note, any note. I want to say middle C, but let's just go for any tone to begin with, without using something like an Arduino. I want to learn how to do this with just the raw circuits, because people used to be able to do this. But anyway, that's it for this video. Hope you liked it, and see you in the future for more on capacitors and more with circuits. I feel like it's getting more interesting now. So, bye.